So I've got a question here. 20 kilo box is pulled by a rope. The tension in the rope is 50 newtons at a 30-degree angle. The coefficient of friction, which will be along the horizontal plane, is 0.1, and we want to calculate the acceleration of the box. Now, first of all, before we start, let's draw a forces diagram and see if we can see what's going on. So that could be my horizontal plane, and that could be the box that's resting on it. We've got 20 kilos as the mass, so I can write that there. And we're given a force of 50 newtons at a 30-degree angle. So let's write that one there. So 50 newtons is our magnitude, and our angle is 30 degrees. So that's the forces we've got acting on it, and the coefficient of friction is 0.1. So that's all written in there. So what's the acceleration? So next thing I need to do is I need to write all the forces that are acting upon it, as well as the ones in the diagram. So we've got the force of gravity acting on the mass of the box, which is mass times the gravitational constant, which is 9.8. And then there'll be a resulting force in a vertical plane, which we can just call R. Now, counteracting this force, there'll be a force in this direction, which will be the force F. So that will be the resulting horizontal force. So first things first, let's calculate these two forces F and R. So R, that will be mg, which is our mass times our gravitational constant, minus any vertical, which will be coming from this force coming from here. So as it's not moving upwards, it's moving across, they should be equal to each other. So therefore we'll have mg minus, now the force acting on this in a vertical, we can calculate by calculating the length of this and its magnitude. So as our angle here is 30 and it's opposite, that will be sine of 30 times the magnitude of the force, which is 50. So that's minus 50 sine of 30. Okay, now the force F. So the force F will be the magnitude of the force going in this direction, and as it's adjacent to the 30-degree angle, we can use cosine of 30 times the magnitude of 50. So it's 50 times cosine of 30 degrees. Okay, right. Now our equation for our forces, we use force equals mu times the resulting vertical force. So if we write that as F equals mu times R, we now need to multiply our R by the coefficient of friction. So that equals 0.1 times these forces here. So mass is 20, so we'll have 20g minus 50 sine of 30. Okay, right. So now we've got these forces. Now we can use Newton's second law when we have something parallel to the plane. So using force equals mass times acceleration, what we can use here now is we'll have the resultant force will be 50 cosine of 30 minus F. So therefore mass times acceleration, that will equal 50 cosine 30 minus our resulting force, which will be, I'm going to write that as 1/10. 20 g is 9.8, so I can write that in, minus 50 sine 30. Okay, let's do some calculations on that. So now we can have, to get acceleration on its own, we can now divide by the mass. So we'll now have 50 times cosine of 30. Cosine of 30 is root 3 over 2. So it's 50 root 3 over 2. Minus, divide all these by 10. So therefore that could just become 2. And that can just become 5. So then it'll be minus 19.6 minus this value in here, so put that in brackets, 50 sine 30, which would be 5 sine 30. Sine 30 is a half, so that would be minus 2.5. Okay, right. Now this we all divide that by 20. So therefore we put that in a calculator our resultant acceleration will be approximately, so let's change that to an approximation, meters per second squared, and that's to 2 decimal places. Okay,